Good day, this is the Professor, CBMD PhD, and today's Thursday, August 10th, 2023. It is 3:15 and 21 seconds, AM Eastern Standard Time, and today's research, human scent. So let's hop to it here. Human scent receptors could help sniff out nerve gases and new sensor. Date August 9th, 2023. Source, American Chemical Society. As some estimates, the human nose can detect up to 1 trillion different smells with its hundreds of scent receptors, but even just catching a quick whiff of certain chemicals known as nerve agents can be lethal, even in tiny amounts. Researchers have now developed a sensitive and selective nerve gas sensor using these human scent receptors. It reliably detected a substitute for deadly sarin gas in simulated tests. Nerve gases are often very potent, requiring highly sensitive sensors to detect them quickly and accurately. One method of boosting sensitivity combines human scent receptors with nanomaterials, such as reduced graphene oxide, to create a bioelectronic nose. And since these nerve gases are still highly dangerous, even in laboratory settings, many scientists rely on safer substitute molecules instead. In the case of the sarin or Solomon nerve agents, dimethylmethylphosphate is a common replacement. Previously, the receptor protein HOR2T7 has been used to detect dimethylmethylphosphate, but it can only do so when the nerve agent substitute was in liquid form rather than as a gas. And so, the researchers wanted to design a nose of their own that was both highly sensitive and selected for the gaseous form using nanodiscs containing the HOR2T7 receptor. And to create nanodiscs, researchers combined HOR2T7 with a membrane scaffold protein and other lipids. The HOR2T7 squeezed inside the scaffold almost like an inflatable inner tube, which kept it upright to readily bind dimethylmethylphosphate. The discs were then stuck to the reduced graphene oxide layer of the sensor, which was decorated with nickel atoms to help hold the disc in the right position. Even when exposed to compounds with similar shapes or smells, the sensor only detected dimethylmethylphosphate and was sensitive enough to sense a concentration as low as 0.37 parts per billion. The team also showed that the device was suitable for real-world scenarios, such as smoky conditions, and during repeat tests. Though further experiments are needed, the researchers say that this work shows that the human scent receptors are useful components for highly sensitive and selective gas sensors. And this is the Professor of Space Technology, Microbiology, Bioinformatics, and Teacher of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.